Okay, filtering rows with filter. We saw how to do this, and we saw putting brackets around it also shows you the output. We used the equal for our logical test. We wanted to test whether the month equal 1 and the day equal 1. Of course, we can use these other logical operators to perform filtering tests. We can use greater than or equal, less than or equal, and we saw equal. We talked about this already. It's a common gotcha. It's a common bug in the code. I still do it, where I'm typing quickly, and instead of using equal, I use a single equal sign in what's supposed to be a logical test. And you'll get an error message. Hopefully you'll get an error message, and it won't just do something you didn't expect and not tell you. You'll get an error message. So keep an eye out for that. Another gotcha, this has nothing to do with, well, I guess it does have to do with filtering, because you might want to filter all rows for which a certain variable is equal to a particular value. If those of you who have RStudio open, go and do this. Type A equals square root of 2 times square root of 2. Whoops. Fine. What is A? It's 2. Okay, and what's B? Let's make B equal to 2. What's B? 2. Is A equal B? No. Oh no. That's kind of disconcerting. I mean, we have airplanes that are like using autopilot and math to fly around. So, anyone have any idea why that's happening? It's a little bit of a computer sciencey technical thing, but it's important to know about. Yeah. One of them is a float and the other is an integer. Well, let's try it like this. Not exactly. Almost. I mean, let's make them both floats. And B equals 2. A equals B? No. You're getting there, almost. Any other ideas about why that's happening? Yeah?
Is it because of the rounding error?
Rounding error, yes. Kind of, yeah. It's a kind of a rounding error. Because of the way computers represent floating point numbers, they don't represent them with infinite precision. There's always some rounding error when computers represent a floating point number. They can represent integers without any rounding error, up to some maximum. But representing floating point numbers, there's always some rounding error, and sometimes it's tiny. Sometimes the error is like 0.0000000, like 20 zeros and then a 1. Teeny tiny error. Nevertheless, it's there. And so when you do comparisons like this, the language will say, no, they're not the same. You know, is this how to do it? Format long? No. I forget. There's a way in R to show more decimal places. Right now it's just showing 0 decimal places. But if we showed the full representation of A and the full representation of B, B would be 2.0, A would be 2.000000000, and then a 1. Because of this square root times square root operation, each of those operations involves some teeny tiny representational error. So the point of me showing you this is sometimes you might want to filter rows where, kind of like we did here, where month equal 1, day equal 1. In that case, it was fine because those variables were stored without any floating point error. If you create a new column that involves some arithmetic combination of other columns that are floating point numbers, you're going to incur some degree of floating point error. And so then when you use an equal comparison, you might miss some rows that are actually equal to within some tiny tolerance, but not strictly exactly equal. Does that make sense? It's a bit of a nuisance with computers, but it's real. Yeah, so this is the more technical description. Computers represent numbers actually in base 2, in binary, zeros and ones. And some numbers in base 2 have infinitely repeating digits. Just like 1/3 in base 10 is 0.333333 forever. So a computer has a certain number of bits that can represent a number with. So just like if I were to say to you on an exam, write down the value of 1 divided by 3. That's question 1. Go. And one of you writes 0.33. I might say wrong. One of you writes 0.333 and 100 of them. And I would say, wrong. One of you wrote 0.33 and you wrote a million threes. And I'd look at it and go, wrong. Right? No one can get the right answer because we'd have to write it infinite to be exactly right. But if I said, write the value of 1/3 to within 3 decimal places, then you can say, okay, 0.333. Correct. Right? So if you're trying to compare floating point values in a filter, then instead of using equal, you can ask if the difference between the two is less than some tolerance. That would be the better way of doing it. And R has a convenient function called near. So you can ask if two values are near each other. And you can tell the near function, the near command, how near they have to be for them to be near. So if I use that for the thing that was false before, R says, yeah, they're near enough to be the same. And you can adjust that tolerance if you want to. Okay, I know that was a slight deep dive on computer sciencey stuff, but it's important because it's true when we're dealing with computers and numbers. Any questions about that? Yeah.
So when it comes to like floating point numbers, right, are we able to, is there a function where we can just round to a specific decimal place and then compare?
Yeah, so the question was, instead of using this, can we simply take two floating point numbers that have some representational error, and can we sort of chop them off to some number of decimal places? Yeah, you can do that. I don't remember off the top of my head what to do, but yes. I know that it's doable and that it's easy, I just don't remember in the moment what it is. But if you're interested, email me later on. I'll find it. Yeah. There might be a round function, like round. Well, that will round up or down. Yeah, there's something like that, where you can tell the number of decimal places. There's another version of this error that's even easier to demonstrate. Does 0.1 plus 0.2 equal 0.3? What's the real answer to that? Yes? No. It's disconcerting. And you can try that in any language. Try it in Python, try it in MATLAB, whatever language you want. It's going to say no. ChatGPT will probably say yes. Although that's an interesting question, actually. I don't know. Should try it. No, someone else can try it. I won't try it. Okay. For integers, it's okay to use equal because there's no representational error for integers. Computers can represent integers exactly, up to some maximum. Logical operators. So in the example I showed before, we asked for all flights where the month was equal to 1, comma, the day equal 1. That comma is, I kind of skipped over that, but what we're implicitly doing there is we're finding cases for which both of those conditions are true. The month equals 1 and the day equals 1. That's what the comma implies. If we want other logical operators besides and, we can do that as well. And there's a lot of different logical operators. So and looks like this. If we have a bunch of cases x and a bunch of cases y, the overlapping part, x and y, is the shaded region. Those are the flights for which the month equals 1 and the day equals 1. And the white regions are the cases that don't meet both of those criteria. And in R, the AND operator is this thing called an ampersand. On my keyboard, it's above the 7. So you do shift 7. and that will give you and. There's also logical or. That's a vertical line. On my keyboard, that's on the key above the return key. Shift backslash, I guess. And an or looks like this. It will give you all cases where either X or Y is true. Oh, no, sorry, that's X or. Where's or? There. Either X is true or Y is true. That's the or. So the overlap and the non-overlapping parts. There's also a not, which is an exclamation point. We could ask for flights where the month is 1 and the day is not 10. That would select all the days other than 10. And so a not, where are we here? Yeah, Y and not X, X and not Y. There's also this logical thing that you might encounter called XOR, which is exclusive OR, which is X or Y, but not X and Y. I don't know why you would choose that to select rows, but just so you know that exists. Okay, so you can ask for things like flights that departed in November or in December. So filter the flight's data frame, and here's my filtering command. I want month equal 11 or month equal 12. We can ask for flights that were not delayed on arrival or departure by greater than 15 minutes. Okay, that's a little bit more complicated. So here's one way we can do it. Give me all the flights where the arrival delay is greater than 15 minutes, or the departure delay was greater than 15 minutes. So those are both delays. We want the not delays, so we put a not in front of all of it. So we define a delay on arrival as greater than 15 minutes, a delay departure greater than 15 minutes. Those are all the flights that were delayed. We want the flights that weren't delayed, so we put a not in front of it and put brackets around it. We could also do that like this. The arrival delay is less than or equal to 15, and the departure delay is less than or equal to 15. That might be easier for us humans to parse. If you're a coder, that might be easier for you. Well, that might be okay for you to parse as well, but I don't know. For me, that's a bit easier to parse. Arrival delay is less than 15, and the departure delay is less than 15. So, whereas in that first example, we had a series of logical operators separated by a comma, that always implies an and. If we instead just have one command after the first comma, we can string together any series of logical operators we want. Sort of combine and nest any kind of question we want to ask about the data, any filter we want to implement. Questions about that? About those two ways of doing it? Yeah.
So, do the comma and the ampersand basically have the same function?
So the question was, so do the comma and the ampersand perform the same function? Not exactly. I mean, kind of yes, kind of no. When you do the command like this, if my intention is I want month equal 1 and day equal 1, then that will do it. But strictly speaking, this isn't acting as a logical operator. We're just getting a set of two different logical tests. And the filter command assumes that if you give multiple logical tests separated by a comma, it's an implied and. If I try to use and in, how should I do it? Let's do it like this. If I try to do on time equals filter, flights, comma, arrival, delay. Well, in that case, it would work. The answer is no. A comma isn't literally the same thing as an ampersand, but functionally, the way it was used in that first example, it does the same thing. Here's another way we could have done it. Arrival delay is less than or 15, less than or equal to 15, comma. Now, see that this, this kind of makes it seem like what I just said isn't true, because those look identical except one is an ampersand and one is a comma. Yeah. Functionally, in this kind of situation, you can do either one. But literally speaking, a comma in a function call like that is what's used to separate arguments you pass to the function. And an ampersand is a logical and. But
Yeah.
you understand?
Yeah.
Okay. That's confusing. Okay. Any other questions about those logical operators before we move on? I think that's all I wanted to talk about logical operators. Okay. R uses the value NA, capital NA, to denote missing values, and NA stands for not available. So if you're looking at a data set and you see a value that is a capital NA instead of some number or a string, that it's R's way of coding missing data. An important thing to know is NAs are contagious in subsequent operations. So here's an example. If I have a vector, x, 1, 2, 3, 4, 5, okay, x is just it's a vector, it's a list of numbers, and I compute the mean of x, it's 3. If one of those values is a missing value, let's make this one a missing value, okay? 1, NA, 3, 4, 5. And now I compute the mean. The mean is NA. So the NA in the data contaminates the subsequent operation on that data. Yeah.
What about the median and mode?
Median and mode? Let's try it. I think it's also contagious. Yep. Oh, maybe R doesn't have a mode function. Standard deviation, yeah. Basically anything, even the sum. If I take the sum of x, that's NA. So there are special versions of some R commands, even logical operators are contagious. There are some special versions of R commands where you can tell them to ignore NAs. So compute the mean but ignore any missing values, and it'll operate on all the values except the NA. So that's something to know about as you're working with these data frames. If you have like a data frame with 336,000 rows, like our flights data set, and somewhere in that giant spreadsheet is like one NA, and then you do some math on different things, and the result is NA. It's because that NA is contagious. So usually, we'll see, usually when you compute summary statistics on a data frame, you can tell it to ignore missing values. The filter command only includes rows where the condition is true, and by default, the good news is by default filter does exclude NA values. So NAs are not contagious for filtering. But for things like logical operators or summary, as we'll see later, they are. Okay, that's all I wanted to talk about filtering. You can read more about filtering in the R for Data Science book online if you want. But that's basically the basic idea. Rows go in, and only a subset of the rows come out, according to whether they match some set of logical tests on the values of the variables, the columns. Okay, next one is arrange. Arrange is kind of like doing a sort in Microsoft Excel. It doesn't select or filter out rows, it simply changes their order. Here's an example. So here's our flights. And if we call the arrange function on flights, and we give it the names of 3 of the columns, year, month, and day, it will sort by year, month, and then day. If we do arrange flights, comma, departure delay, then it will sort the rows according to the departure delay. And by default, it's always smallest to greatest. So you can see in this first one, the years all start with 2013, the month is January, the day is 1, and if we showed more, then you'd see then the day would be 2, then the day would be 3, then the day would be 4, and then the month would be 2, and so forth. In this version, where we've asked it to arrange by departure delay, the month and the day are all scrambled now, and the first row is the flight that had the smallest departure delay, actually a negative number. What's a negative delay? It means it was early. Yeah, so that doesn't happen anymore. At least not with Air Canada. Air Canada, again, was voted the North American airline with the worst on-time performance. Number 1. Again, anyway. So smallest to largest. You can use the descend command on that variable if you want to do it in the other way around, largest to smallest. So that's the largest departure delay down to the smallest. So this doesn't change any of the data. It just reorders the rows. All the observations are still there. All the variables are still there for each observation. We're just reordering the rows. That's it. Done. That's a range. Why would you ever want to use a range? And then I'll get to your question. Why would you ever want to reorder the rows of anything? Yeah?
You want to see like greatest and least of a certain variable.
Yeah, so the answer is if you wanted to see things from greatest to least in some variable. Yeah, so if we're doing kind of a human visual exploratory first pass on a data set, you might want to arrange it different ways to see what the data look like. For large data sets like this with hundreds of thousands of rows, probably you wouldn't use a range on raw data like this. Probably you would use a range on some summary of the data, some much smaller thing that you wanted to rearrange the rows for. Anyway, that's a range. There'll be your question.
Just when it comes to a range, right?
Yeah.
How does that work for characters?
How does it work for character strings? So how does it, that's a good question. Why don't we try it? So, flights, what's a character string? Let's try tail number. That's the tail number of the aircraft. So let's arrange flights and tail number. Oh, it didn't show us tail number because it's too many rows. So let's glimpse that. So what did it do? Let's see. Where's tail number? D942DN, D942DN. So D comes before N, that's true. So it's doing some alphabetical sort, A to Z. If it's a combination of letters and numbers, I guess it's going to sort by the first character first, and then if that's all letters, it'll do it alphabetically, and then by the next character, and if that's numbers, it'll do it numerically. And then by the next character. So I think it just goes character by character. How does it handle symbols? Like there's a question mark or an exclamation mark? I have no idea. That's a good question. You can play with it and tell us next time. Okay, the next verb, the third one, is select. Just like filter took a subset of the rows of our data set, according to some criterion, select will take a subset of the columns. So it'll grab all the rows, but only selected columns. So let's say we only wanted to look at our flight data frame. We only wanted the year, month, and day. We didn't want all this other stuff, tail number and carrier and arrival time. We would say select from flights just year, month, and day. And it would give us all 336,000 rows and just these 3 columns. If we do the shortcut, if we want everything from year up until day, because it's year, month, and then day, we can say year, day. And it'll take from year and then everything up until the day column, and it'll give us that. If we want everything except year to day, we can use a minus. That means take away the following. So it gives us all of the columns except year, month, and day. So that's a little shortcut you might see. There are other helper functions beside that minus sign you might see with select. There's starts with. If you want to take all the columns whose names begin with some character string, you can do starts with. Same thing with ends with, or even contains. You can give it a number range, and that will match whatever you give it here, and then the numbers. So if you have columns like x1, x2, x3, instead of typing x1, x2, x3, x4, x5, x6, you can just say num range x, 1 to 6, and that'll do a shorthand. You can look at the help documentation for select by typing question mark select. Did I show you this? In R Studio, if you type question mark and then the name of the command, it will pop up a little help description in this window here. And it's usually a description of what that thing does, and then a description of the different ways it can work. And then usually at the end somewhere, it gives you some examples of its usage. So that's a handy thing. The other handy help thing is if you, like me, often, this is only good if you remember the name of that thing. If I don't remember the name of something, then how can I search the help line? You can do double question mark and then any keyword, and it'll search the entire help documentation for pages that include that keyword. So if I don't remember, something to do with columns, columns to row names, or if I just do column, it will show me everything in the help that matches column. And then I might find what I'm looking for. Okay, so single question mark for something we know the name of, and then double question mark for a search. Okay, any questions about selecting? That's really all I wanted to show you. It's not really rocket science. Before we break, why would you want to do this? Why would you want to just select certain columns out of a data frame? Yeah.
If you want to get rid of like the relevant columns.
Yeah, if there's a whole bunch of variables in your data frame that you're being given maybe that aren't relevant to the work you're going to be doing subsequently, you might as well just chop them off so that from that point on in your code, in your analysis, you don't have to deal with it. It's not occupying memory, and it's not being spit out to the screen, and it just helps you focus on just the things you're interested in. Yeah, for sure. Or if you want to do some operations on a data frame using just some columns and then, save that to a file that you can give to a colleague or a collaborator or someone else. And you don't want to give them this giant thing with 300 variables. You're really only interested in 5. You can chop them off and just deal with the ones you want. Yeah, that's the basic idea. Okay, why don't we take a short break? We've just got 2 of these commands left, mutate and summarize. Summarize is a little more complicated than select, so we'll take a few minutes to go through that. But let's take a 10-minute break.